as I wrote to you in my email, I really admire what you do, the kinds of questions that you try to resolve with your work. I think it's just so fascinating that we have people such as yourself, who try and answer some of this like big and fundamental questions that, like, in some ways touch upon what it means to be human. So yeah, I very much appreciate you like taking the time out to just chat with me a little bit here. Yeah.
Delighted to be here.
Yeah. And first of all, I want to ask you, I think for many people who do the kind of work that you or like pursue any kind of career, it starts at a very young age, right? And could you perhaps like go back and tell us a little bit about like how it all began for you? Because for me personally, it was, I'm not a scientist, but I love science and I loved talking to like various scientists for many different fields. And for me, it was like reading about like Stephen Hawking or Einstein or this great scientists, and or reading books by them and have it all. I'm just curious, like what like got you started on this path that you've been pursuing ever since.
Yeah, I think like you, I was probably always interested in maths and science. And yeah, the gateway activity was reading some of these popular science books that try to take these great ideas and explain them in a way that I could understand as a child. And I'm just so delighted with the universe that it's given me the opportunity to do that as a career. So follow those interesting questions and try and pursue answers.
But didn't you have like any particular, example of someone who really had, a big impact on you? Maybe like a high school teacher or whatever, or it was more like
Yeah, I'm super lucky that I've had lots of people who supported me throughout. I remember one high school physics teacher who called Tony Ayres, who was just super, in touch with, some of the great questions, and very much enjoyed talking to him. But even before that, reading, various popular science books, sort of all across the board, I just was totally voracious and just loved reading that kind of thing. Reading Scientific American, which back when I was a child was like a sort of excellent view into sort of what's going on across the board in science, and just sort of I remember almost being frustrated as a kid, being like, are they going to figure it all out before I'm like old enough to contribute? And no, they didn't figure it all out, and no, we still haven't figured it all out. But yeah.
And for example, at a place like Stanford, right? It's where you work, and it's amazing to me because there is that like I know like the kind of entrepreneurial culture is like extremely well developed, there, and like it seems like like almost everyone who graduates from there, from Stanford, like goes on to start their own company, or whatever. And do you like, in terms of like physics, do you also feel the sense of like just like lots of people get together and bounce ideas of each other, maybe I don't know if you get to talk to people like Lenny Susskind. I know he's also based at Stanford, or maybe a scientist from other fields. I'm just curious, as someone who's never been like even like remotely in like within that environment, like what it's like to be at Stanford and as a physicist.
Yeah, I mean, I think the you draw a connection between physics and entrepreneurship. I think there is some kind of analogy, and even within physics, there's a distinction between experimental physics and theoretical physics. And at least in high-energy experiment, the experiments I think of as like the megacorp analogies. The sort of there's like CERN, for example, this huge experimental physics collaboration, which is thousands of people, and everybody has their own little place within it. And maybe that's the analogy of Microsoft or something, with some some huge company, and everybody has their own specialized bit to play. And then there's theoretical physics, which is my field, which is maybe more like startup culture. It's like a few people sitting there and who have to be the jack of all trades because there's only going to be one or two or three names on the paper, and you're all pitching in for everything from sitting around brainstorming the ideas, coming up with the ideas, developing the ideas, abandoning the ideas, or pivoting when you realize they're not doing too well, all the way through to finishing the paper, writing the paper, talking about the paper. And it has more of a sort of move fast and break things attitude rather than the more careful approach taken by the experimentalists. But I like it. I like that aspect of like your, think about one thing for 6 months, and then there's like a new group with a new group of people, and you're thinking about something completely different for the next 6 months and coming up with ideas and just trying to generate good thoughts about how the universe could work.
Yeah, and when I have someone like you, I can't help but ask like a question or two about Einstein, though, because it's like I guess he's in many ways somewhat of a hero, to like physicists, and physicists revere him for what he's contributed to the field, and when, for example, we talk about general relativity, right? It seems to me like he's like Einstein's theory of gravity. It seems like such an to me such an incredible leap in terms of like how everyone else around Einstein like thought at the time, and it just fascinating to me, what it must have required, or what it must have been like for someone like Einstein, to come up with this like radically new, like vision or understanding of the universe. And for example, if you had the chance to talk to him, today, to Einstein, like if you do a bit of time travel, maybe there is like some insight that you would like to glean from him, to what would you like to ask him, in terms of like the way like his mind worked, or how he like solved this like mysteries of the universe, and all. Just fascinating.
Yeah, Einstein, I mean, he made a number of big leaps. Perhaps the most astonishing to me was the invention of general relativity in 1915, in which he reconceptualized how space-time works, how gravity works, and connected these thought experiments that he just came up with sort of basically via pure thought to questions about the evolution of the entire universe. And then was basically found to be correct with experiments within a very short number of years thereafter. That to me is one of the most impressive things that any human has ever done. And somewhat unusually, there's this idea of the solitary genius, who just sort of sits down and thinks, and that is typically not how it works. Despite that idea, typically, there's if you look at, for example, the history of quantum mechanics, what was developed around the same era. Many people, including Einstein, made important contributions, but it was the work of many hands. And Planck had various ideas, Heisenberg, Einstein. I mean, a whole host of people, all of whom contribute to the construction of this beautiful edifice. General relativity, in some sense, it was in the air. There were, precursors and like other ideas, but perhaps more than any other physics idea in the last few centuries, this was just one guy sitting down, thinking very hard, and then emerging with the most beautiful theory that humanity has ever created. I mean, that basically doesn't happen, and it happened once, and he's like some Ayn Rand hero or something who just sort of went away and sort of came back with this thing, and it's pretty extraordinary. And obviously he deserves a huge amount of credit for it. Like the only other thing that I can think that's somewhat analogous is Darwin inventing the theory of natural selection and relativity. Again, it was sort of in the air pre-Darwin, but at the same time, it was a singular act of creation by putting it all together in the way he did. So yeah, sort of super impressive. I mean, at both that and many of the other contributions he made to other branches of physics, Einstein has a very well developed and very well deserved reputation for brilliance. I don't know about them. I mean, the sort of slightly darker side of Einstein is that he then did kind of go off the boil for the last few decades of his life. And he even asked some of the same questions in a more embryonic form that we're asking today, to do with how you combine gravity and quantum mechanics. He thought about those questions and didn't, compared to his earlier work, did not make a tremendous impact on those. So I guess the question, to recast your question, which version of Einstein am I getting? Am I getting young Einstein? But if I am getting young Einstein, I don't know.
Yeah, let's say the kind of 1905, version of Einstein, when he had his miracle year, and he was quite young.
Yeah, it would be super interesting to see how he would work with some of the ideas of today. His ability to sort of see through the complications right to the essential physical principle. He was not, there's different ways to contribute and be a superb theoretical physicist. Some people are just, incredibly powerful calculators who just absolutely, attack things. Some people are more, their great strength is the opposite of that in some sense. The ability to ignore the noise and just look for the sort of one central simple thing at the heart of everything. Einstein was more in that second category. It will be very interesting to see how he would do today. I think he'd probably be pretty good at these, these thought experiments around quantum mechanics of black holes. I think that's the kind of thing that would actually speak well to his sort of very conceptual mind.
Yeah, but what's also fascinating to me is that I've heard this from somebody, I guess it was Sean Carroll, or I don't remember who is exactly, but his general relativity is it's amazing because it's in some sense much smarter than he was, because he obviously didn't believe in the existence of black holes, and he was writing papers in the 30s, saying here's why they don't exist, but now we know for sure that they're real. And he didn't, think of a Big Bang or our expanding universe, but these things that have come out of his own theory, just just incredible, because the theory itself contains so much richness within itself that even Einstein, who had invented it, hadn't really thought of all the implications of it, and famously didn't even find the first exact solution, right? It was Schwarzschild, right?
I think that's a great perspective. That's true of general relativity. It's really true of many of our physics theories and scientific theories, is that they're smarter than we are, particularly those that are well cast in mathematics, is that often you write it down and the mistake you make isn't falling too in love with your theory, it's not taking your theory seriously enough. And that the implications of your theory, if you really believe them, are often more extraordinary than you first realized. And so, you mentioned all of these later developments in general relativity that Einstein could have figured out, but failed to. Even his understanding of black holes, Schwarzschild wrote down this. He wrote down the equations of motion of space-time. Schwarzschild, it took pretty soon thereafter, wrote down our first solution, which is the solution that was called the Schwarzschild solution nowadays, is the solution for a black hole. Einstein could have done that, and he didn't. But I guess he just didn't trust it enough to do it. And then, having done it, he misinterpreted for many, many years and was like an impediment in many ways to the correct interpretation of Schwarzschild's solution. So if you know black holes, at the very center of the black hole, there's the singularity. And once you hit the singularity, you're dead. You're going to get mangled up by the infinite or almost infinite tidal forces, and that'll be the end of you. But there's as well as the singularity at the center, there's also something called the event horizon. The event horizon is much further out, and if you go sort of much further out than the event horizon, then the singularity, you get this event horizon. At the event horizon is the point of no return. Once you're close, you're inside the event horizon. If you get that close to a black hole, then no matter how hard you fire your rocket, you're doomed to hit the singularity. So you're not dead yet, but you're doomed. But this fact that the event horizon is, it's somewhere that if you pass, you're doomed, but it's still, it still looks smooth and everything's normal there. There aren't huge tidal forces. There's not violence at the horizon. That's something that we understood, but it took us years to understand, even though in some sense it's kind of obvious from Schwarzschild solution. But the way that the Schwarzschild solution is written down, there's what we call a coordinate singularity, which means it's just some weirdness of the way you wrote it down, but actually no weirdness of space-time. That's a very, very important fact that amazingly took about 50 years after Schwarzschild first wrote down his solution for people to fully understand. It wasn't until the 60s that people really understood that the event horizon was a place where it was the point of no return, but nevertheless you could pass the point of no return and nothing weird would happen to you immediately. That important fact was not appreciated for 50 years, and Einstein contributed as much as anybody to the confusion surrounding that very important point.
And from what I read also is that like Oppenheimer played also a key role in that, right? And like one of his most famous papers was like regarding the death like state of like high mass stars, but it was like largely ignored because it was published as I know on the same day that the Nazis advanced on Poland, so like the world didn't pay much attention to it. But I guess
yeah, people had other things on their mind, though. Of course, Schwarzschild, when he wrote down his solution, it was in the middle of World War I, and he was actually an artillery officer on the front line, which displays a commendable ability to continue to think about black holes under such circumstances. And not only did he continue to think about black holes, he thought of something that Einstein had missed. But yeah, so Oppenheimer wrote a paper that clarified our understanding of black holes. As you say, that was more than 20 years after Einstein's work. And then it was 20 years even later than that before people really understood the full picture.
Yeah, and one of the like big implications of Einstein's theory is like we have this expanding universe, and then we discover that it's like expanding at a like at an accelerating rate. The expansion is like is just we're living in a universe that's like accelerating, and it seems like it's going to like everything will ultimately like evaporate away, and like wither away, and everything. Like we have this like heat death notion, and does it ever like frustrate you when you like think of like all the things that we humans have done, and like in many ways we want to leave some legacy of like that gives us meaning, because a large part of what we do is just try to leave some legacy for like future generations. But if all of that is gone, like yeah, how do you make sense of it? I don't know, like just maybe philosophical question, but just curious to hear your thoughts.
Yeah, I think that's both a philosophy question and a physics question wrapped up in there. Let me deal with the philosophy question first. Yeah, what is the value in doing something if you know that one day that thing will be swept away? You pose that question at a sort of civilizational level. One day there may be a heat death of the universe that would erase all history of us. So what's the point? People similarly, ask even questions even a more mundane level that, our lives end in death. What is the point of something that only lasts for a short time? There are even people who go out to the Black Rock Desert here in the west coast of the United States every year, and build a city there and then burn it down at the end of the week. And even they find meaning in what they do. And I think partly that's does being ephemeral make something less valuable, or is like ephemerality just a feature of it, and that it means that you should enjoy and express while you're doing it. And that's the important thing. And that any dream of eventually encoding it into a memory of our distant descendants is kind of missing the point anyway. The point of life is to be lived, not to be remembered. So like that's one like philosophical, and I don't really have anything more to say on that topic, but that's one philosophical question. I will say there's also a physics question wrapped up in there, which is it in fact the case that we're doomed to a heat death? Is it in fact the case that the amount of entropy in the universe keeps going up? If there's an upper bound on the amount of entropy in the universe, that means that we will eventually run out of free energy, and everything will come to a close. Not just the human era, but the information processing era, and then it'll just be heat death forever, perhaps. I would say that that's an open question in physics, whether that's true. And it's an open question that touches on questions of cosmology, questions we do not fully understand, and that data keeps coming in, changing our opinion on that question. It's a question of what the expansion of the universe going to look like in the distant future. It's also a question of, which gets back to some questions that Einstein grappled with, and solutions to Einstein's equations. Is the universe going to keep expanding forever? If it does keep expanding forever, is it going to expand at an accelerated rate, or is it going to go more slowly? And perhaps even whether our civilization or a later civilization can impact that, can take our fate into our own hands and impact whether we hit a heat death or not. So yeah, both at a level of physics, I don't think the heat death is guaranteed. We've got a lot to learn, and the future is a very long way away. So we may well figure out a solution before that. And even if it is, going to happen, I don't think that makes life meaningless.
But don't you ever have like moments of, I don't know, existential anxiety or something like this? Just kind of putting the sheer scales of the universe, like in both space and time. Doesn't it like ever make you insignificant in some way? Or I don't know, like as somebody who studied this so much and knows so much about it. Yeah.
Yeah, I mean, it is possible to be intimidated by the scale, even forgetting about the universe. The fact that there are billions of people on this planet, and I'm just one person. The fact that history is long, and I'm just living in a brief window. All of these things have the power to intimidate. Similarly, the fact that there are an Avogadro's number of other stars in the visible universe, that's a pretty large number. Does that just mean we're insignificant? There's another perspective, which is I wish it was larger. Only 10 to the 22 or something stars out there. I hope that one day we're going to go out and colonize all of them and bring consciousness, spread it throughout the universe. I think it's a shame there's only 10 to the 22. I wish there were more opportunities for us to, bring happiness to new worlds.
Yeah, and I also know that you spent some time studying in Oxford, right? Yeah, in England. Yeah.
That's right. Yeah.
Yeah. And
I did my undergraduate there. Yeah.
Yeah. And how would you compare, for example, the kind of environment you're immersed within at Stanford and versus what you like experience in Oxford? Would you say like this are like different worlds, or in some sense similar? Just curious because I never studied in like either like Oxford or Stanford, but these are like very prestigious institutions, and yeah, I'd be happy just to hear from somebody who's got this life experiences.
Well, I've had a great time at both Oxford and at Stanford. There is quite a lot of traffic between Oxford and the Bay Area, both intellectual traffic and then people moving back and forth as well. It's both the places that take both science and philosophy, maybe I should say, seriously, with a sort of techno-utopian tinge to it. I'm also at a different stage of life than I was. Oxford, I was an undergraduate, just learning all these things afresh, doing a major in philosophy, which really took me into some of these places. And by the time I arrived at Stanford, I was more embedded in theoretical physics research. I think there's a lot in common. Obviously, Stanford is in the middle of Silicon Valley, and it's sort of I find this whole area to be, for somebody interested in questions of science and technology and the future, I find the Bay Area to be, the center of the world for that kind of thing. And Stanford is the intellectual center of Silicon Valley in many ways. So, that greatly appeals to me. This feeling that we're here and we're building the future, and that if we do it right, the future is going to be, beautiful, and we're going to make a tremendously positive future for humanity. That's a feeling that's here in the Bay Area that I haven't found exactly that anywhere else in the world, including Oxford.
Yeah. And did you ever imagine maybe doing anything different, or was it always about physics, or science? Yeah.
I take interest in many different things. As an undergraduate student paper was very interesting to me, and I ran with a friend of mine, we ran a sort of business doing importing academic gowns to Oxford. So I've explored all of these other various routes, but to me, as long as the universe keeps giving me the opportunity to try and wrestle with some of these biggest questions, be they the fate of the universe, what's happening at the very smallest scales, or now some of these sort of very interesting questions about what happens to neural networks when you just keep ramping up the number of parameters. What kind of things can you create that way? These seem to be questions of such profundity and such urgency that as long as the universe keeps giving me the opportunity to think about this kind of thing, it's hard to think that I would do anything else.
Yeah, and there's been a lot of talk lately. I'm sure you're aware of this about physics is in a crisis, right? It's stagnating, and it's not really making much progress as a field. And I think part of the problem is perhaps that we already understand so much about the universe, right? About nature, and it's kind of difficult to make progress under this in these circumstances when you already know so much, and you don't know where some new anomaly perhaps might come about. But I'm just curious, what sort of response would you have when people say that it's just in crisis, or physicists maybe are lazy or stupid, or whatever. Why we don't have revolutions like we did in the first half of the 20th century, or whatever.
Well, it's in the nature of physics subjects that first they're too hard and you can't make any progress on them, so they're not really physics, they're philosophy. And then suddenly you can start to answer some of these big questions, and then eventually the big questions have been answered, and there's not much left to do except in that subfield. So that arc has certainly played out in a number of fields. For example, nuclear physics. 100 years ago, we didn't understand nuclear physics at all. It was a complete mystery. People were not much better than, well, certainly 150 years ago, but not much better. Didn't have much more intelligent to say about it than the ancient Greeks did. It's just that was couldn't really say much. And then starting in the 20s and 30s, we got all of these experimental results that were unexplained, and it was time to try and patch them together with our understanding of quantum mechanics and our understanding with other aspects of nuclear physics. And then it was just a super hot field in the 20s and 30s and 40s, obviously, and the 50s. But then as time passed, we basically answered every question that could be answered about nuclear physics. And all of the remaining questions were sort of too hard. We understood why we couldn't address them with the technology at the time. And so nuclear physics is just not the hot subject just as an example, is not the hot subject it used to be, as far as the scientists are concerned, physicists are concerned, because we either answer questions or we recognized that they were not available to answering using the tools that we had. And so, there's this kind of sigmoid curve to any given subfield. The question is, that happens to every subfield of physics. What was considered a hot topic 150 years ago, Maxwell's equations is not a hot topic now. We understand Maxwell's equations as well as we're likely to probably, maybe there'll be some new revolution, but for now, progress on understanding electromagnetism is at the fundamental level is not happening. So the question, there's always a sigmoid within any given field. The question is, can you add enough sigmoids together to make constant progress, or is that just the entire of physics sigmoided? It is. Another field that sigmoided more recently is particle physics. Basically, we got too good in the sense that we can build a multi-billion-dollar particle accelerator like we did at CERN, and our current theories are sufficient to explain at some level, or at any rate predict, absolutely everything that ever comes out of that particle accelerator. We don't have things that cannot be explained. Maybe if somebody built a $100 billion particle collider for us, we would, but not, at the levels that taxpayers are willing to support building particle colliders. We won. We have the standard model of particle physics. It essentially explains everything that comes out of the particle colliders. So there's nothing. You can then invent more exploratory questions, but there's nothing in your face about an urgency there. Okay, so yeah, in some sense, physics is a victim of its own success. Nevertheless, physics departments, there's a lot of interesting work going on in physics departments, partly just by turning our baleful eye to other closely related fields that are amenable to the same techniques. Obviously, many physicists have gone into biophysics and used physics ideas to understand biology. Currently, huge numbers of physicists are flowing into the field of artificial intelligence and using physics ideas to explain these very powerful machines that we're building in data centers and try and sort of understand as an empirical matter what they do and if we can kind of understand their behavior from a more theoretical perspective. So yeah, some branches of physics are saturating. We've learned everything there is to learn. Other branches of physics we're still making progress on. I think the future for theoretical physicist style ways of thinking about the world and the universe and science to be making positive impacts across science is bright.
And since we don't have much time left, I'd like to ask. I come from Ukraine, and as you know, we've been dealing with this Russian innovation for more than 3 years by now, and it seems like it's not going to end anytime soon. I was curious, maybe is there some message or some insights that maybe you have gleaned from your studying the universe, studying nature, that perhaps you think that would be useful for us Ukrainians to hear about, to be exposed to. I don't know, maybe some messages that you would like to give us, maybe how to navigate this or how to deal with this in a more effective way. I know, of course, obviously it's very difficult. There's a lot of uncertainty in the air, and we don't know how long, like I said, this could last. But yeah, maybe there's some messages, maybe some words of wisdom that you would like to share with us. I'd be happy to hear.
Yeah, that is I feel way above my pay grade to know what to say in answer to that question. It's cold comfort, but the history of science is full of people making tremendous contributions to science under extremely trying circumstances. We mentioned Schwarzschild, inventing the black hole solution under extremely trying circumstances on the Eastern Front in World War I. Yeah, I feel like making comments beyond that is beyond me. I wish you the best of luck, obviously.
But maybe there's just some like general messages, I don't know, or maybe you bring up this topic with some, with like people in the United States. I don't know if that's brought up at all in like your discussions with friends. What people say, yeah, in like Stanford or in the US about this situation.
About the Ukrainian situation, yeah, I mean it's we obviously follow it in the newspapers, and yeah, it's rough. I yeah, I'm very sad that this is happening to you, and everybody obviously admires the way that the Ukrainian nation has come together over the last few years and seems to put down a coherent response, and also the way that I mean, that you haven't just given up on thinking about, like, I was very excited to receive your email, like, as a young Ukrainian who is under these trying circumstances still able to maintain a podcast in which you think about some of the the background of your current Zoom screen shows the entire world, and above it the entire universe. Your ability to continue to think about those things is admirable.